Welcome everyone for this episode 5 of this MLOps Zero to Hero journey and complete full course as well. So as I was continuing from the last 4 episodes, and this is the 5th episode, that is I'm going to 31, when you can call algorithm and when you can call model. So basically you've been getting stuck here, so you don't understand. Most of the people is having a confusion, what is algorithm, what is model, and when to call model and when to call algorithm. So before that, let's understand some other associated topics as well, uh, playing around it. Let's say, what is your data science and what is your machine learning and what is your AI? Whenever you're going to search over the internet, you might having a lot of confusions on it, and you'll be getting different definitions over there. Most of the people are who is very good at the English and they would be understanding, even though people are good at the English, but we won't get the exact information, and our brain cells are not able to connect properly, and when, how it will be collected. Even I have faced some of the questions like when an ML model turned as an AI. Oh, is it something like that? Machine learning model will be turned as an AI, and that is the second shape of an machine learning model. Is it something that, or your data science or your deep learning will be turning into an AI? These are all subset fields actually. So that thing we need to understand basically. So I'll be going to give you as much as uh, a good understanding on this video, like what is all these things and what's going behind the scene. Let's understand now. Data science, which is nothing but the science, a discipline of the science you are applying over the data. So it can be any data. So you have uh, any data, so customer data, infrastructure data, product data, inventory data, any data like weather data, you take anything, okay? So that is your data. So you are applying some techniques, some discipline, and some kind of techniques on it. So fine tune it and make it as a finest data with some techniques. So that is basically a data science. That means you are collecting, okay, from the different sources, cleaning and trying to extract some of the features, and then you're putting into the one place as a finest data. So that is your data science thing will be. From that, you can actually go for the ML training. Okay, for that, you can go to the ML training. So this data is something like your chef. So let me also pull some guy like this. So example, a chef who is collecting all the thing for your curry or recipe. So he would be collecting all onions, tomatoes, everything, and putting it over there and cutting, chopping everything and putting it over there in a one nice bowl where we wanted to ready for the cooking. Okay. So that is something like you can, all the ingredients you can collect it as a data. So some historical data will be there. Okay. And you have a live data, it's batch data. So a lot of data will be there and you will be applying some of the techniques on it. And then you will understand the one pattern. So where this understanding the structure of the data like EDA, feature engineering, everything will be coming into this picture. So all this you can put it under this box as a data science side, and then you will be getting into the ML side. So before we are going to the ML, and let me also bring up one more image, so which will be giving you an understanding of how this is. So I think if you see this, I think it is not edgy. Let me bring this to the image. Now, if you see this, deep learning, data science, and artificial intelligence and machine learning models. So these are all subset things actually. If you see, deep learning is a subset of machine learning, and machine learning is a subset of your AI. Now, Deep learning is something from this data, it will be understanding the structure and it is trying to learn the pattern which it can train and then teach you over your mission so that it will understand it will be going to connect the all the neural networks and then it will learn the pattern and then it will tell you something. So that is the deep learning where on top of that machine learning will be coming into the picture. So in this machine learning we will be using algorithms actually. On top of that we will be using AI. So many times I would be also having some questions in the starting of my career and students of my students also who are regularly attending my classes and all, they would be also shoot me multiple times in the corporate trainings also. So who are already working. There is some confusion between that. AI is separate, ML is separate basically. It is a subset. But how if AI is something that can be worked without ML model, is it something right? Yes, it is something right. So AI was working from the 1950, basically. From the 1950, if I'm not wrong, as per the Google. Okay, 1915, but it is something on the rule-based thing. So AI was working from that onwards actually. So AI is something you're programming a mission, you're programming a technique that it has to do on a rule-based mechanism. Example, a patient uh, went to a hospital and you're applying if else thing. If a patient is sick and having a fever, if condition and true, then go and check for the flu. If it is no something and else, then go for something. So this kind of conditions you are applying, that's a rule-based thing. That is an AI actually, where it is going on a rule-based thing. Then what happened at that time? This AI, you just forget about this ML and DL, okay? Just this AI was, you have to program it. You have to program it explicitly for everything. Like now I said one example. Now I am giving a lot of cat images, dog images and all. For each everything I need to feed it. Again, so I have 100 rules like that. For every 100 rules, I need to write all this 100 rules in it, all this 100 conditions in it. I have to explicitly program an AI, then that can be performed as expected. So that is an AI. And it is very hard for the engineers to every time that you need to do that. Okay. And that is a become a problem where your ML is came into the picture. Now what ML will be do? Instead, you have a very large data set. You have a lot of large data set basically. So you have a large data set and you will be programming it. It is not going to be done in a one day job, right? So you can have a different data also. You can have a different data also like this and you will be again programming to it. It is a complex thing. Instead that you can use a machine learning algorithm. You can use a machine learning algorithm and feed this all data to this algorithm and this algorithm will learn a pattern by analyzing your data. Then it will come up with one output of you are having multiple algorithms actually. You will be having multiple algorithms actually here. So with that, it will be learning. So what happening here? So there is a problem. There's a problem. You will be having multiple AIs. Supervised learning, unsupervised learning, supervised AI, unsupervised AI, and reinforcement. So these are all there actually, the types. And in order to understand this AI, I'll give you a picture. In order to understand this AI, we have two things. Understand AI by type and understand AI by behavior or a functionality. You might heard that narrow AI, general AI, and theoretical AI. Okay, so these kind of things. So we'll come into the picture. I'll tell you even that one as well. Let's finish up this. Now I have, so this AI, which I don't want it to be programmatic, means explicitly program, and then I would be having multiple problems on it. So I wanted to use this machine learning algorithm. So here I would be having a multiple algorithms. Okay, you have regression, okay, linear, and you can use classifier, okay, BERT. You have many algorithms like this, many algorithms. According to your business problem, let's say you have a data, tabular data, you have a numeric data, you have a descriptive data, text data. So by understanding, you have a image data, okay? By understanding this, you can select a algorithm wisely. I'll be also covering a separate episode on it. How to select model wisely. That is the title. Okay. So that we will be going to discuss in more deeper on the based on the problem statement and the based on the data type and what we want it to be. So every time your problem will be not going to be solved by using single model. Okay. So there would be a multiple models actually. Okay. That will also come into our AI. I'll tell you. So this is a problem right now of this AI basically. That's why I'm going for the machine learning with some algorithms where I'm going to put everything into it so that my algorithm will learn the pattern. So algorithm is nothing but again, it is going to learn the things from your data as a new pattern and then it will give you, if you're using classification, then it will classify it. So that is the result. And how accurately, what is the confidence, okay? So how accurately it was doing that? So that is you need to tune it. You need to tune the algorithm. So with some parameters and something that you have to tune it, the algorithm, while you are getting into the training process. So that's how you can train your algorithm and make it predict, okay? Then understand and evaluate it with your test and evaluation data. And if it is okay, there would be a sum of the metrics for each algorithm. Okay, we will be discussing very clearly in coming up classes. So with that metrics, we can decide that whether this model is giving me correct answer or not, or correctly classified or not. We have a different algorithms. We will discuss on the based on the problem statement. Okay. So that is the main motto of this algorithm. It's a logic. Basically, there is a logic in the algorithm. That logic will be work in a mathematical way where the machine can, it will learn and it will tell the machine to be learn this pattern. So that is an algorithm. That's where your machine learning we will call. Okay. By using this machine learning, AI is there. Now everything is machine learning based AI. Now everything is machine learning based AI. That's how the system grown this much fast because of the machine learning. And the lot of hazards are done, right? And now if you come to the AI part, let me, where is my eraser? Okay, so let me remove this part. Now, so if you talk about the AI side, and you would be having, let, let me keep it. And now AI. So we can understand AI by the type or the functionality or the behavior actually. So if I say there is one thing called narrow AI. Narrow AI. What is this narrow AI? Narrow AI is perfected one job actually. It will perfected one job only. Example, Alexa. It's perfect Siri. It's a perfect at one thing. Google Maps. So perfect is one thing. Your Netflix recommendation model, that is perfect at one thing only. So it cannot do the other job. So that is the narrow AI, which is weak AI we call actually basically. And then we have a general AI. So which is hypothetically, if I say that this is this is something like intellectual, it will perform an intellectual task, something like a human, but still it is not exist right now. Still in the research, and we are close to it. Basically, if I would say we are close to it, basically. And then there is a super AI. Oh, sorry. Oh, let me write down here. General AI, and then super AI. Super AI again. It is something like your same like human intelligence that is going to be applied in a sci-fi concept. Okay, that's more intellectual, like a human, and with the behavior or the function. If I wanted to understand with the behavior and the function, so there is a reactive missions, reactive response, I would say. Okay, so reactive missions means with no memory. No memory in the sense, you can say a calculator. Calculator is something, when you type something, then it will be calculated and give it to you. Or chess game. Chess game is also one of the example. It won't store or preserve that what you have did in the last game, right? Completely empty. There is no memory, and what input that you are giving that time, based on that, it will give you output. So that is reactive missions actually. And then we have a limited memory. Then we have limited memory. What is this limited memory? Again, it learn from your past data. From your past data, it will learn. So then based on that, it will give you some predictions and all. So which is kind of a self-driving cars. When you see the self-driving cars, it is going, there's an AI actually it works, and there are multiple models. Basically, when it is input having some signals, some traffic signal, pedestrian is going on, or bicycles and the vehicles, to identify everything it will be identifying. In the behind the scene, multiple models are working. So image, okay, the behind the thing, multiple models are working. So that is something where you can't end up in AI with a single model for your use cases. You'll be having the multiple models behind the scene. Okay, even your chat GPT are also having multiple things, right? When you are uploading image, it will be using that. When you are uploading the voice, it will be also. When you are uploading video, it will also. When you are text, it is also. When you upload Excel, it will also. When you upload PDF, it is also. So these are all different capabilities, right? So AI is having this many capabilities, but how thing is behind the scene it is happening because of your ML models, because it is trained on it. A simple thing I can say, your machine learning is your brain and the AI is a body. Okay. Now example, you have a multiple models. All the multiple models you given some set of data and you put it in a sensor, and that model is learn the data. Example, when I'm walking in a house, with my movement, motion, speed, the light has to turn on. Okay. So this is a basic problem in IoT, you can say. So my model has to learn on this movement, image capturing or a video or sensor based on thing. Uh, then it is already learned, which was working perfectly, and then you connected the AI system. Now what happens? Your AI system will detect this and send it to your model, and your model will be doing the. However, it will be detect that. Then your AI will be take the decision. Okay, turn on the light or shut down the door like this. So this is something is an AI. Like our body is an AI. Now something is running in my mind and my hand is moving. So this is an AI. So this is a basic difference, guys. Okay. And we have a theory of mind and self-aware AIs. Even theory of mind still in the research stage only. Still not, it is not confronted anything. And self-aware also, it's a purely AI is intellectual and in consciousness, like imagination side. So that is the thing. And if I would say when I would be calling model and when I would be calling uh, algorithm, the actual point. So this is my algorithm, algo, and I have data. I have data. So this data, when I would be feeding to this algorithm, it's an algorithm, it's a recipe. You're putting some onions, oil, everything, and you're making it curry, right, with the ingredients. That is an algorithm. Okay. And then after train, so this is a training process. This is a training process. With your train, after training process done, and then there will be a output it will generate, that is your artifact, pickle, right? Or artifact, anything, job leap or pickle. The artifact will be generated after your algo. Okay. Then you would be using this artifact. Okay, you would be using this artifact. I can combine like this. Then I'll move like this. And this one is nothing but your model when it is going to deploy. This is model where you would be using for inference. So this is inference. Inference means with some data, you are expecting your model to be predict some value. You are giving some input values here, and based on the whatever the train and learn the pattern, your model has to predict some value as an output. Okay. So here, so when you are deploying this after training or where it is doing inferencing, this is called model and this is called algorithm. Simple. That's it. When you have artifact, you can use it with inference and deploying, and this is algorithm, and this is pickle, this is model. And now there's a one more question who frequently students are frequently asking me that when an ML can be turned into AI. No, guys, it's it's a kind of, I can say ML is a tool kind of thing and a subset of the AI. There is no exact point that ML will be turning into the AI. AI is something where it will be using the decisions, reasoning, and predicting all these things. So this is the capabilities of the AI, but you're using machine learning to advance these capabilities in a easier pattern. So there is no exact point I could say that. So here, this point, ML will turn into AI. No, AI will use ML things to make it more advanced in the reasoning. Okay. So a more effective way to deliver the output. So that is the AI actually. So there is no point. You can, yes, you can say that AI can be using your machine learning capabilities. So that is the thing of this episode 5. I hope this was informative to you all. If it is informative, please like and share. And I would be uploading some coming up videos with some practicals on the algorithms and the models of how to select a model wisely for the my problem statement. So that is the biggest thing actually based on your problem statement and the data types, and while you are selected also, even after selected also in your training time, and how would be you have servers and what infra that you need to select, how you have to calculate at the enterprise level. It is not that so easy. You have to do lot of brainstorming sessions, then only you will come up with a one conclusion. See, providing the solution is not a big deal, guys. The problem, bringing up the problem statement, having a finest final blueprint is the problem. We need to have that, decide, then we can have a solution very easily. Because once we have a clear understanding and the statement and the blueprint, then we can easily work on the a proper segment part. So, so that's it for today's video, and see you guys in the next video. Thank you.